Welcome to 49cc Scoot. My name's Brent, and today I'm ready to start assembling the RC1 engine. Alright, let's get started. So the first step is going to be make sure your cases are clean. I just use dish soap and water and then dried them off with compressed air. You can use gasoline. That's actually what Malossi says, is to use gasoline to clean the cases and then dry them off with air. Kerosene would also be acceptable. Whatever you do, if you're using chemicals like that, make sure you protect yourself and protect your eyes. But these are already clean, so the next step for me is going to be to install the bearings. These are the crankshaft and gearbox bearings that I want to install right now. So I'm going to do the crankshaft bearings last. I'll start off with the gearbox bearings. If you're using Malossi's supplied bearings only, then you've got two bearings to install. The first one will be this 6203. It's a sealed roller bearing, and that's going to go right in there. It's pretty obvious because it's the only place it could fit. And the other is a needle roller bearing, 16 millimeter inside diameter, and that's going to go in that slot right there. I have one additional bearing, which is a 12 by 18 by 12 needle roller bearing, and that's going to go right here. Now this is for the primary drive shaft, and Malossi says to leave this spot empty, and I believe it's standard on the Piaggio to leave that empty. However, Malossi's primary drive shaft is machined on the end, and it will accept this 12 millimeter bearing. The reason that I want to use this additional bearing is because I have a lot of experience with the 1E40QMB Chinese Minarelli two-stroke scooter engines. And those have a fairly similar setup to what the Piaggio engine does, or this RC1, for the primary drive shaft. Those use a large spherical roller bearing near the gear on the primary drive shaft, and then on the CVT side, the side of the shaft that goes into the CVT, not into the gearbox, the end of that is also supported by a bearing inside of the CVT cover, and that's the two primary bearings that it uses. But then on some models, they had a third support bearing, which is in the same location where I'm going to be putting this additional bearing in this RC1, and some used them and some didn't. For years, every setup that I owned used only two bearings, and I consistently had problems with play in the primary drive shaft and bearings wearing out prematurely. Then I found out about Eton scooters, and they use that third bearing for support. So I switched over my setup and I started using the third bearing, and after that I had a whole lot less issues with play and with bearings wearing out. So that's why I want to try it in here. Again, I have no experience with a Piaggio platform. It could turn out that this is a bad idea, but I do know that Ryan Ott has been using them for a little while and I haven't heard of any issues. These bearings could be pressed into the case, but I typically do something similar to what Malossi recommends. I heat the cases, cool the bearings, and then you hope that the bearings will just drop in with little effort by hand. Now Malossi doesn't actually say to cool the bearings, but sometimes that helps in the heat differential. So basically what you're doing, you heat the cases up and the cases are going to expand. You try to cool the bearings down so they will contract a little bit, and then that should create enough clearance that they drop in. You'll need some sort of heat source. I choose to use a heat gun. You can use a torch. I've done that in the past, but the heat gun works better for me. To cool the bearings, you can use freeze spray. What I use is actually a duster, but the trick to that is if you hold this upside down, it will spray out very cold like freeze spray. You'll need a way to monitor the temperature of the cases so you know where you're at. Again, we're shooting for 130 to 140 Celsius or around 275 Fahrenheit. So I'm going to use my multimeter with the thermocouple installed. It's got a little probe there, and you can just put that somewhere near where you're working, but you don't want to directly put heat right on that. Another option would be one of these non-contact thermometers. I've used those a bunch of times, so basically you just pinpoint the area that you're trying to check, and it should be fairly accurate. Because there's so much heat involved, you're going to need some sort of protection for your hands. I'm going to use welding gloves. Those are pretty much meant for heat like this. And I'd also suggest protecting whatever surface you're working on if you care about it. So you can see I've got a sheet of plywood down here. I have just done this on my workbench top before that's covered in a rubber mat. And the problem with that is usually the rubber mat will get hot enough that it warps and then it never lays right after. So you're better off to just be prepared in advance. And I'm going to try this out. I will tell you from using wood in the past, you can get wood hot enough that it will smoke and burn. So do not cause a fire, just be aware of that when you're doing it. You may notice that earlier I said that hopefully these drop in easily with little effort. That's not always the case. If these get even just a little bit canted or tilted, sometimes that's enough for them to hang up, and then they start to transfer the heat away from each other. They start to equalize in temperature, and suddenly you don't have all that clearance and they're not going anywhere. So I like to have some stuff handy in case that happens. Whenever you're driving in or pressing in bearings, you want to apply the pressure nearest where they're being pressed or driven into or onto. So in this case, I'm driving them into the cases, so I would want to apply pressure out here around the outside race of the bearing. If I were driving these onto a shaft, then I would want to apply pressure only to the inside. So if you pick out a socket, that should only apply pressure to the outside of these, and you want that to be very close to the size, but just a little bit undersized, because you don't want the socket to run into your cases if you're driving it in. And again, I've got one for this bearing, one that fits nicely with this one, and one for this one, all lined up, ready to go if I need them. And then of course you'll need something to help you drive them in, so keep a hammer or a mallet handy. Now I will say that pressing them in the rest of the way would be the preferred method most likely. However, if you can catch these right after it happens, you might get away with even just light taps that get them in there, and I've never had an issue from driving one in this way. I'm pretty much ready to get started, so I've got my case lying flat down on the board, and that gives me a nice straight shot down into each one of the bearing races. Now I need to set up my probe to monitor the temperature. I don't want to be blowing the hot air directly on it, but I want it somewhere close. So I'm just going to put it in this bolt hole here, get it seated down in the bottom there. Alright, here we go. I'm at 130 now. I'm going to keep going because I know that I want to freeze my bearing. So I'm going to shut this off for a minute. So I'm going to try and get it up a little higher. That way when the temperature drops, when I quit heating it, it should still be up to where I want it when I'm ready to put the bearing in. Alright, I've made my way almost to 140. Actually, it's at 140 now. I'm now going to move one of my bearings over here and cool it down. You can see I've got one glove off. I'm going to try to just touch the bearing with that and not the cases, because it's, again, really hot. And sometimes if you leave a glove off, it's a little easier to get this started, but of course be careful not to burn yourself. So, got my duster here. Just going to hold it upside down and spray this thing. It's going to chill it down a lot. You see the frost? I'm going to see if I can get this down in there as straight as I can, which is not very straight. That's why I've got this handy. I'm going to try to see if I can knock it down there. I'm going to leave that for now because it's already had enough heat transfer that I'm not going to get anywhere easily. I'm going to have to really hammer it in. So instead of doing that at the moment, I'm going to go ahead while the cases are still hot and see if I can get these two in. Maybe I'll get lucky and it won't be so difficult. Same process, going to heat it back up till it's at the temp I want, and then we'll try it again with those bearings cooled off. And when I'm doing this, because this thing has a rubber seal, I'm not going to aim this at that seal at all. I'm going to make sure I'm really targeting these areas where the bearings are going. I'm going to continue to let that warm up a bit, and I'm going to freeze this little bearing. That one got closer. Any chance here? And it took me too long still, so I think probably not going anywhere, but we'll try. Camera's falling over, so that's not helping. There we go. The leg on my camera's tripod collapsed while I was trying to get that in there, but I did manage to get that driven all the way in. And yeah, that's also not going to go. I'm not having much luck getting these things straight. Yeah, that one's already frozen. Okay. Now I'll go ahead, switch back to my socket. And I think that's it. It appears to be all the way down there. Now I'm going to try to do this one, and to me it looks like this side right here got pushed in more. It kind of fell in at an angle that way. So I'm going to try to tap it over here with the wooden end of my hammer, see if I can't straighten it out, and maybe it'll drive in pretty easily after that. I'm going to try to finish this off in the press. I've just got a piece of wood under here to protect the case a little bit. And if you're wondering, the reason that I just went ahead and hammered the last ones in or drove them in is because the way the case is shaped, it's easy to set this one up. With the other two, it would be a little more difficult, so I thought it'd just be easier to go ahead and finish driving them in. Alright, that's finally in there. You can tell because if you look right here on the edge, you can see that the bearing is pushed all the way up against the case. While I'm in here, there is a snap ring that goes into a groove right above that bearing. And you'll probably see that there are some markings here around that groove. That's because I have tried this at least 5 times, and these snap rings keep wanting to slide off. They've got a little bent and crooked over the years, I guess, and now they're fighting me with this one, like everything else is today. So hopefully this will be the magical time and this will actually go in there. This is not supposed to be difficult, but compress this, make sure it's pushed onto there well, then compress it and try to get it into that groove. That didn't quite go down where it should, so I am just going to take a screwdriver and hope that pushing this down finally finishes this off. There it goes. So that just popped into place, and my snap ring's installed. That certainly didn't go how I would have preferred, but that's real life. Some days those things will drop right in there, or at least drop in and then you can just push them down with a socket or whatever, and it doesn't take a whole lot of effort. And some days it's like this, and it fights the whole way. But now I can move on to installing the crankshaft bearings, which is going to be a really similar process. You do need to note a few things about these bearings before you get started, because as you can see, they're different. Most scooter engines would use the same bearing on both sides, not the case for the C1 and RC1. So this is a spherical roller bearing with a polymer cage, and that one is going to go in the small crankcase half, or the stator side. And with this one, you have to pay attention because this side there is a raised edge in the center. The center of it is raised, and on this side it is not. It all sits flat. This raised section needs to face toward the crankshaft. So this is the side with the raised section. It would go into the case like that. This is a cylindrical roller bearing. It's got some polymer on both sides as well. But one of the big features here that is different than most bearings we'll deal with is that this center section is removable. So this section will go into the crankcase, and this will go onto the crankshaft, and that will allow the crankshaft to slide in and out of this bearing on this side without having to be pressed in and out. So that makes assembly and disassembly easier. This bearing will go into the large crankcase half, the CVT side, like that. Or really you'll install it like that. Just like for the gearbox bearings, I've got my temperature probe here near the area that I'm working with on the case. I'm going to try to heat this up to about 130 to 140 degrees Celsius, and then we will hope that these bearings drop straight in and aren't a lot of trouble this time. This thing's up to right around 140, so I'll go ahead and cool my bearing. And we're gonna cross our fingers that this thing goes in a lot better. I've actually got a piece of wood. I'm gonna try and push it down with that so I don't have to align it. If it doesn't go in, which sort of is. All right. Thought it was going to go easy. Not quite. We're going to try and finish it off right now. Getting close. Okay. Appears to be seated all the way down there. I'm gonna make sure I'm touching this with my glove here and flip it over and take a look. Trying to look inside there just to make sure. It appears that that is all the way seated. So that one's done. I'll just let this case cool off for a while I do the other one. There we go. That one went more like we'd like it to. Just a couple of taps after it's started to seat and it's in there. Now I want to install this collar onto the crankshaft. It's going to go on the CVT side of the crankshaft and it's going to face just like this. So this lip down here is going to be up against the back of the crank. That way it can slide into that bearing. Now I actually should have done this before I did that last case half, so that thing could retain heat and it'd be easier to install this side into the bearing. But it is what it is. This is the first time I've used one of these and I just kind of forgot my order here. So while that's still holding a little heat, I'll try to heat this up, cool this down, and then hopefully this will drop on. Quickly freeze spray the area right here where that bearing is going to sit. Now hold this upright and we're going to hope that this thing drops into place. There it goes. Again, that's kind of how it's supposed to go. You can see that thing got pretty hot. My gauge is saying about 280, but it may have got hotter than that. Whatever the case is, it's on there now. That didn't take long, so these cases still feel very hot. Let's see what they're at. They're at maybe 80 Celsius, so I'm going to heat these a little more. Going to be really careful. I'm not going to try to apply heat really closely to that polymer cage there, but I want to get some more heat in there. At least get them over 100 Celsius. All right, I'm showing right on 120 for that. I'll quickly shut this off. Move this a little bit here, and then I'm going to freeze spray this side of the crank. Hopefully I've got enough left in here. Yeah. Grab the case. You need to make sure your connecting rod is coming through here. You don't want it jammed up in there or some weird stuff. And then I'm going to try to drop this in place in there. There it goes. I let everything cool to room temperature because I no longer should need that heat differential in order to get things together. This should slide into this bearing. So that makes it easier to work with everything. You don't have to wear big bulky gloves or worrying about burning yourself. And I also prefer that everything is cool if I have the opportunity when I apply my gasket maker or sealant. Before I move on, I will say, if this doesn't go on for you like it did for me, then it can be pressed onto the crankshaft. I'll put a link in the description. I know that Pitobread, that used to be a member of the forums, actually has a video showing this. And he's very good at the process. He shows you exactly how to support this properly and get that on there right if it doesn't go well. Same deal, sometimes this crankshaft won't go into the crankcase. If that does happen, then your best bet is to use a crank puller tool like this. So basically you've got a way to adapt this to your crank. Should be another nut that fits onto the threads of your crankshaft. You'd screw that on. This would be happening on the other side. I'm just showing you here because it's out in the open up in the air. You would thread this on, and then this part of the tool is up against the case. Then you've got a nut here. So this is directly attached to the crankshaft, and when you thread this nut on, it starts pulling the crankshaft toward it, and that will let you pull the crankshaft into the case. And you may actually need this later, depending how the crankshaft is, because it's best to kind of have it centered. So it's possible that this will need to move a little bit. But if it won't go in, then you're going to need one of those. Don't just go hitting it with a hammer. You may have seen me hitting bearings with a hammer, which may or may not be the best idea, but definitely do not hit the crank with a hammer. All right, now I'm getting ready to put the cases together. So I'm going to need a sealant on all the surfaces here. So this surface, and then all the area here. And I'm going to use Yamabond 4. There's Yamabond, there's Honda Bond, and then 3 Bond I've used more than anything. They're all pretty much the same thing. If you have a preference, go ahead. I had picked this up for some reason, so I'm going to go ahead and use that. You don't need a whole lot of it. If you smear a bunch on here, it's just going to squeeze out and get everywhere. You just need a really, really thin coating. So usually just use your finger and smear that on. I would suggest wearing gloves, because most of these things, if you read them, have some sort of cancer risk. So wear some gloves and protect yourself. But just put a thin coating on one side of the case half. Now what I'm hoping for is that I can stand this up, align these two. You want to make sure you've got the dowels in this half. It should come from Malossi with a dowel here and a dowel here. Make sure they're in there and they're in good shape. So get everything aligned. Make sure your connecting rod is coming through where it should be, even though it shouldn't be an issue at this point. And you can start sliding this into the other one. And then push these together, just kind of working it together. All right, so those will actually butt up to each other. Now that I've managed to get everything pressed together, I'm just gonna lean this up a little bit and start my bolts in here. Remember, you've got one long bolt, and that's gonna go way up here in this corner. Now I'll just start snugging these down in a crisscross pattern. So go over here, up here, down there, etc. And while I'm doing this, I'll say you want to make sure you're not actually pushing the cases or squeezing the cases together with these. If the cases are not going together, then you should use a crank puller like I just talked about to pull the two case halves together. But right now, I'm just working on getting these seated kind of firmly, not putting a whole lot of torque on there. And I'll finish off by once again in a crisscross pattern, torquing all of these to 12 Newton meters, which is Malossi's spec. While it's still fresh, even as thin as I coated this, you can see that there is sealant seeping out of there. So you may want to go and just wipe that off all around and clean it up a bit. Now you need to do at least a couple of checks. So first, hang onto the con rod just so it doesn't bang into the cases, and rotate the crank around. It should move very easily and freely. Then take a look and make sure it looks roughly centered. If it's moving freely, then most likely it is at least roughly centered. For most people, if the crankshaft spins freely, then they're probably going to move on from here. But you can actually try to measure the clearance on each side and see if you can center this crankshaft. So you can take a pair of feeler gauges and see what you can get to fit in each side. And in my case, I've already gone through this process, and I know it is 41 thousandths of an inch of clearance over here and 56 thousandths of an inch of clearance over here. So you add those two together, that's 97 thousandths of an inch total, and then divide 97 in half, and that is 48 and a half thousandths. So ideally, if I wanted this thing totally centered, there would be 48 and a half, thousandths of an inch between this side in the crank and between this side in the crank. You're never going to get it that accurately dialed into the center, but you can try if you would like. So for my example, if I wanted this to be totally centered, then I would need to pull the crankshaft this way about 7 to 8 thousandths of an inch. To do that, I would use this crank puller tool. So I'm going to start off, I've got this adapter that goes on the crank, and then I have another adapter that will match the threads on there. And then this piece will pull up there, and I can thread this onto that. So now the idea is that this will slide in and butt up against the engine cases in there. I will then tighten this nut up against it. This rod here is attached to the crankshaft via those adapters that we just saw. So when I tighten this down, it will start to pull the crankshaft this way. And what I can actually do is put the feeler gauges in here, and while they're still in place, I can tighten this down a little bit, and if it starts grabbing those feeler gauges, I know that I've gone far enough. Getting close. Okay, now it's grabbing them probably too much. Let me just back the tension off and see what happens. There we go. Okay, so now that feels pretty good on that side and pretty good on that side. So I've got somewhere around 48 thousandths of an inch on both sides there. That's about as well centered as you're ever going to get it. So then you can just remove the tool and the crankshaft should be done. Actually, you're not quite done if you follow Malossi's instructions, because they show that you should do an axial or end play check just like this. So you set up a dial indicator on the end of the crankshaft, and you want to make sure it's as straight on as you can get it this way, and also as straight as you can get it this way. Now your dial indicator should be secured, and you need to hold the case still while you try to move the crank. So be careful when you're doing this, because even if you put pressure down on the case, it may change how the dial indicator interacts with the end of the crankshaft, and that could throw things off a bit. Then you're going to grab the end of the crankshaft opposite the dial indicator, and it really doesn't matter which side you're on. You could switch the dial indicator over here and push on this side. It shouldn't matter, because you're just measuring how much the crank is moving this way. And then try to push and pull and see if anything changes on the indicator. So the only change I see on the indicator is, I think, from me touching the case. Try one more time. Okay. Yeah, so I'm not detecting any movement, and neither is the dial indicator, so that looks good to me. Now I've got 3 seals that I want to install. This one goes in the gearbox over a bearing that I installed earlier, and these 2 are crank seals. It is very important to choose the right sizes of seals for the crank, because there are multiple seals in this kit that look very similar. The seal that goes over the crank on this side is a 19 by 30 by 5 millimeter. And the seal for this side is 18 by 28 by 7. I'll start out with this seal, and the process is going to be the same for all of the seals. So the number one thing is to make sure you lubricate the inside of the seal with grease. I use Mobil 1 synthetic grease. You can use whatever grease you prefer. But just make sure you get a good coating of it in there. You kind of pack it into the center of the seal. So now I'm going to take this and gently start sliding that over the crankshaft and pushing it into the case. So I'm going to start and see if that goes in by hand. Sometimes they will and sometimes they won't. And that's only going to go partially in for me. Just going to clean off this excess real quick. If your seal won't go in by hand, then you're going to need some kind of driver. It can be really simple. I used to just use this PVC pipe. It's got an aluminum cap on one end that I machined just to give it a little more area, but you don't have to have that. The main thing is it's got to be large enough to fit over the shaft, long enough that you're not going to accidentally hammer the end of the shaft, and you need the end to be smooth. You don't want any sharp edges that could cut the seal. I'm actually going to use this one. I made this myself. It's a seal driver, and I've got ends that I can replace for different seals. Nice flat surface, large flat surface, and similar to the diameter of the crank. So I'm just going to put this up there, kind of center it on the seal, and then start trying to tap it in and regularly check the seal because you don't want to drive this in too far. If you've got something like this, it should stop it, but certain methods it is possible to drive the seal in way too far. So and this one, it's starting to seat down here, not quite seated at the top. So you can just kind of adjust how you hold this and tap it. Here's a close-up look before I move on. Once it's in there enough and it's flush, you should be able to actually see this little chamfer that they put in the case. But again, it will feel basically flush with the cases. Alright, so that didn't go great. Let me give you a close look. The seal didn't want to start for me, and you can actually see that the spring that's inside of there got stuck on the crank. So I'm going to go ahead and carefully remove that. And then I can put that back into the seal. Basically just kind of wrap it around there and make sure it's tucked into the groove inside of the seal. It appears to me that this is too small. It really should want to start, and it's just pushing right up against the edge of there. So it seems like this is too small to me. I'm wondering if maybe this should be the 20 by 30 by 5 instead. But I double checked. I had actually ordered another pack of crank seals for the RC1, and it comes with a 19 by 30 by 5. So that seems to be what they're specifying for this. Alright, so this is a 20 by 30 by 5 that comes in the RC1 kit. This is the 19 by 30 by 5. Only difference is this is a millimeter larger, so that should be made to fit over the crankshaft. I'm not sure if I've just picked out the wrong one or what's happening here, but again, everywhere I've seen it seems to be listed that this is a 19, but I think this might actually work. Yes, see, that actually wants to start. Seals should not be that difficult to get started where they just don't even want to go over the shoulder on the crankshaft. And this is almost in, but not quite. So I'll just give it a tap or 3. And with this one, I'm not as liberal. It doesn't actually have the same kind of groove in there as the other. So I just like to apply a little bit, that way when I insert the axle later, it won't be through a dry seal. But there's going to be gear oil in here at all times when it's running, so it doesn't need a whole lot of it right now. I'm going to work on the gearbox next, so this is just going to be open for a while, and I don't like just leaving this open. So I'm going to stuff a rag in the top, in the reed area, and then get one stuffed in here around the crank. And that way it'll help protect it from any debris. Here's most of the parts for the gearbox. So we've got the cover that's supplied by Malossi. That thing is mostly complete. It's got all the bearings installed, has a clip in there. The only thing you need to do is press the primary drive shaft through this bearing, and then it will have a clip that goes on there, and you've got to install a seal. Then there's the intermediate shaft, And this gear will need to be pressed onto there. And then you've got the axle or the output shaft, and this gear needs to be pressed onto there. So lots of pressing. I would expect that you'd need at least about a 10-ton press to do this. So if you don't have access to that, you may be better off to take the parts that need to be pressed to a shop. I'm going to start by trying to press this primary drive shaft into here. So again, it's going to go like this. It will get a lot of the way down there, but the last bit you have to press in. I don't think this is going to be a really tight fit, so I'm not going to do any heating or cooling this time. I'm just going to try and press it down in there. That one was really easy to press in, and you can see I pressed it all the way down up against the bearing. Now there's a groove right here in the shaft. It should be sitting just above the top of the bearing, and this clip needs to go in there. So I'm just going to take the clip and slide it over the shaft. You'll have to kind of work it down there. Take a screwdriver to help me move it the rest of the way because I can't really reach. And there you can see it just popped into place. I'll go ahead and install the seal to finish this off. Now I'm going to do the intermediate or countershaft and the primary gear. I'm anticipating that this is going to be a tighter fit, so I will heat this gear before I try to press this into it. That one definitely took more force, but you can see this is pressed all the way up against the other gear. And now I'm going to press this secondary gear onto this shaft. You can see we've got a machine section right here on the shaft. I've already measured these. This is just slightly larger than the thickness of this. So I guess basically I'm just going to try to center this in here. I use this piece when I press the gear on, or really I press the shaft into the gear, because I could just push down on the threads and push that in, but I thought maybe this would be a better option because it will align right with a taper on here. There's a little bit of a taper here, and then the inside of this has a little bit of taper on it. So it's sort of self-centering and keeps everything aligned without having to worry about it too much. And again, I'm not putting pressure on the thread, so it turned out pretty well. I was trying to get this gear centered on the machine section of this shaft. So there's what's left over here that you can still see, and there's what we got on this side. It's a little bit off, so I probably pushed it a little bit too far in, pressed it a little too far in, but I'm going to check how this aligns with the gears and see if I need to make any change. So I'm going to slide this in a little bit, just get it started, and then I'm going to put this so it aligns with that gear, kind of move them in both at the same time. And now I want to push this one all the way back. It kind of wants to push itself out because of the way it's designed, the taper on there and that seal. But I'm going to push it in and push this one in, and then we can take a look. As it is now, with both of these pushed in, this gear is right up against this gear. If it's not making contact, it's at least very close. I think it is making contact. Yeah, I think very light contact there. So what I'm probably going to do when I assemble it is use these little spacers. Now I'll put one on each side of this countershaft, just like that. And these are stock for Piaggios, but Malossi doesn't include them, and I didn't see anything mentioned about putting them in there. However, I think this is probably the right way to go, and I know that I did watch a video by Pitobread some time ago, and he used those, and I hadn't heard anything about it not working, so seems like that may be the way to go. So now if I insert the counter shaft with that spacer on there, I can get it aligned, there we go. Then there's a little bit of clearance there, and it seems like it's okay. Now I'm pretty much ready to try and put this together, but I do have these two dowels supplied by Malossi. One needs to go here, and one over here. And these may be pretty tight. Yeah, I don't think that's not pushing in by hand. That one does at least somewhat go in by hand. Got a brass punch. I'm going to see if they will seat without a whole lot of effort. I think that one actually is seated. Try this one. I'm going to pre-assemble things inside of this cover. So I've got the counter shaft, and I'll put one of the shims on there, and then put this in place right here. You can see those mesh up nicely. Then I can go ahead and put this shaft in place, and they all turn together like they should. And then I can add this shim on this side. Now this whole assembly needs to go in here, so just align this shaft through this bearing back here, and then you'll just kind of need to rotate it as needed to get these dowels to align. Now I'm going to do a quick preliminary check. It's not going to tell me a whole lot, but I'll know if anything's way off. So I'm going to hold a little bit of pressure against this cover here, and then I'm going to rotate this shaft and make sure that this shaft moves and that it's not hard to turn. And you can see I'm just turning that with 2 fingers, no problem. So that looks good so far. Now I'm going to bolt this cover on, but this is just for a mock-up because I want to see if when everything is squeezed together, the bolts are tightened down, if I still have free motion here. So you will need your own bolts. These are M6 by 1.0 by 45. M6 by 1.0 by 40 would be the standard, but I'm using cap screws and I've got little washers under them, and these seem to fit fine. So I'm going to go ahead and install these in a crisscross pattern. Well, I said M6 by 1.0 by 45, but apparently I didn't check thoroughly enough because it looks like everything's fine except for 2 bolts. So this one here and this one here will bottom out apparently before you get there if you're using a 45. Alright, so let me back these out. Now I'll tighten these to 12 Newton meters in a crisscross fashion. Now I'll do the same check that I did earlier, just rotating the primary drive shaft, verifying that it rotates the axle or the output shaft there, and that it's very easy to turn. If it's binding up, then it could be something like if you're using the shims that I did, you may need to remove 1 or 2 shims in there because it may be pushing together too tight and holding something up, or you'll need to inspect otherwise to find out what's going on. But in this case, it looks good. Now I can remove all the bolts and take the cover back off. For final assembly, this doesn't use a gasket, so you do need to use a sealant. I am just going to use Yamabond 4, the same stuff that I used to seal the cases earlier. So again, just like the cases, very, very thin coating here on this surface. Before I do it, because I've handled them so much, I'm going to go ahead and just wipe everything down with alcohol real quick and let it dry before I apply the sealant. Now the assembly goes just like it did before. Even though adding sealant shouldn't matter, just for good measure, make sure this still rotates freely. And then, aside from gear oil, we've got 3 more things that we need to install. We've got a drain plug with a copper washer, the dipstick, it's got an O-ring with it. The O-ring was elsewhere in the kit, so I had to slide that on there. And then this little vent for the gearbox. I'll start with a vent. So if you look at the rear of the case, you can see you've got a small hole up here, and then there's a hole for the gear oil dipstick. The vent is going to go in this little hole up here, and it's going to face backwards. You're not going to be able to just push that in, so I'm going to kind of hold that in place, and I'm going to see if I can tap it in with a rubber mallet. Maybe not. So I'll switch to a brass hammer and try this way. There we go. And you'll be able to see there's a little, very small shoulder on there, so just install it down to the shoulder. And you know, I'm looking at this now wondering if it really should face this way, because I'm not used to having a rear disc brake. That appears like it may be in the way, so let's see if I can kind of knock that out of the way a little bit. Just put my hammer on there and see if I can spin it. There we go. I think that should be out of the way of any bolts, and then I can drive it in a little bit more, and that should be good. If I need to, I can probably adjust that later again, put something up against the side that's softer, and just kind of drive it over. The gear oil drain plug goes down here in the bottom of the engine, and I will say I was going to install a magnet on the end of this, but I didn't have any small enough. So that may have to be a project for the future, but I do think it's a good idea to have a magnetic drain plug. And Malossi didn't supply any torque spec for this that I saw. So I looked around, and manufacturers with similar sized drain plugs, this is M8 by 1.25, were specifying between 5 and 10 Newton meters. So I'm going to aim for the middle of that, around 7.5. Now I'm going to add gear oil, and Malossi specifies 100 cc or 100 milliliters, same thing. I'm going to use Mobil 1 synthetic 75W90 gear oil. It's the same thing I use in all of my small scooters, but the choice is yours. I'm going to thread this in just finger tight, then I'll back it out and check the level. I'm pretty much right on 100 cc. And the gear oil is just above this bottom line. I assume it needs to be somewhere between the bottom line and the top line here. So I'll probably add just a little bit more. I figure it'll probably come out of the overflow anyway. That's how most scooters have worked for me. Add a little bit too much and it's gonna seep out of the overflow. Alright, so now I'm somewhere around halfway up there. Depends which side I'm looking at here. But roughly halfway up. So I'll call that good. That ended up being probably about 125 cc, I would say. And then I'll just tighten this down there again, finger tight. That should pretty much wrap up the gearbox, though you may want to put a hose on here and run that down toward the ground on this little port. That way, if it did leak any gear oil, it won't just dribble on the engine. It'll actually go down below the motor and route it somewhere that it won't get on your wheel or tire or brakes. For me, that's easier to do once it's in the scooter. It's a little easier to tell where I want it. And the other thing is I'm just going to rotate this a few times, and maybe it'll splash a little bit of lube around in there. And then I'll call that done. The only other thing that I'm going to do right now is install this water port that goes down here in the engine case. Basically, I'm just trying to wrap up a lot of the stuff directly related to the engine cases. So you should have this port in your kit and also an aluminum washer, and that's going to go right on the back of that. And then you can thread this in. Now I could not find any kind of torque spec for this from Malossi, so I'm just going to snug this up, snug to tight by hand. And this takes a 12mm hex. I actually have the bit here. If you don't, some 8mm bolts will have a 12mm head. You can put that in there, grab it with vice grips, or you can double nut them and tighten it that way. That's going to do it for this video. Next time around, you'll probably see me installing the cylinder kit as well as the reeds and the reed block. But that's probably going to be a couple of weeks, I'm thinking, because if you follow my videos very much, you may be aware that there are 2 car shows a year that I like to take the scooter to and ride around. And Ryan from Pennsylvania actually brings his down for the last few years and rides along with me, so it's a good time. And I do not like to miss those. So I'd like to get this thing in there for the car show. I could leave the TPR 86cc in there if I have to. It works plenty well enough for it, but I'd really love to have this in. So filming takes a long time, even though I know it doesn't seem like it would take long to get the rest of this together. If I didn't have to film it, it wouldn't take long at all. But with me filming it, because I want to share this stuff, it does take a long time just to do the assembly, and then the editing on top of that takes a really long time. So I'm going to continue filming, but there's pretty much no way that I'm going to be able to keep up with editing and doing all of this stuff. I thought I was probably good to go, and then I realized I don't even have an ignition system that's going to bolt onto this thing. The ignition system has to have custom work just to work, and probably some other stuff. I've got to switch out the wheels and the brakes on the scooter and all this kind of thing. So 2 weeks really isn't a long time when you take that into account, and remembering that I'm very slow because I'm filming everything and talking. So yeah, you may not see videos for a couple of weeks, but rest assured they will be coming, and I'm hoping that I'm going to make it to the car show. Anyway, with that said, thank you for watching. Be sure to like the video if you found it helpful or enjoyed it, and subscribe for more.